the way that I look at the risk is that I always use the word risk with opportunities.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Dr. Janaka Ruwanpura. He is a professor at the University of Calgary. He is the vice provost of the entire university, an associate VP of research. He's a professor of engineering and project management. And Janaka does a lot of work with risk very generally. And so we're going to explore today how cyber risk fits into the big picture of risk, inside of engineering and construction and other kinds of projects and organizations.
Then without further ado, let's get into the interview.
Hello, Janaka, and welcome to the podcast. Before we get started, can I ask you to say a few words about yourself and about the good work that you're doing at the University of Calgary?
Thank you, Andrew. My name is Janaka Ruwanpura. I'm currently the Vice Provost International and Associate Vice President of Research at the University of Calgary. At the same time, I'm also a professor in the Schulich School of Engineering, specializing in project management. If I were to give about my connectivity with the university, of course, I look after the global engagement of the University of Calgary, which includes every aspect of it in terms of academic, research, mobility, and industry connections. In terms of the University of Calgary, I think, we are very proud that being a young university, and particularly last year, we became truly number 5 in Canada as a top 5 research university. At the same time, I think the other key element that I want to talk about and might be very interested to hear for your audience is that for 2 consecutive years, University of Calgary is the number 1 startup companies produced, which is actually a tremendous recognition and reputation for a university like us. Whereas when you look at even the top 5, the remaining 4 are, in terms of the scalability and the size, are much bigger. And then also they are older, more than 100 years old.
Cool. I mean, I am an alumnus of the University of Calgary. I'm a great fan of the university. But our topic today is risk. I mean, you are an expert in risk in the context of sort of engineering project management. We're, of course, on the podcast interested in cyber risk, but cyber risk fits into sort of a bigger picture of sort of overall risk management. You've got the risk of, hurricanes and fires and who knows what. So, you're an expert on risk. Can you start us at the top? What is risk? What's the big picture of risk? What are we worried about? What should we be worried about?
Yeah, I mean, Andrew, the key element of the way that I look at the risk is that I always use the word risk with opportunities. And my expertise is mainly in the project risk management side of things. And where I think the key is that we look at every possible thing for a project, that what are those elements, challenges, that uncertainties, that could create challenging and problems in moving ahead with our projects. So I think that's where we look at and say, how do we convert some of those negative things, such as the negative risks, into a better opportunities where we will handle them, we identify them upfront, we come up with good solutions to deal with them, so that we can run projects with minimum impact of risks and uncertainties, so that the projects will be successfully planned, designed, and implemented. And I think that would apply even in your domain in the cybersecurity area, about how do we identify these risks in advance, and then how do we come up with a sustainable, practical solution that would benefit the key stakeholders, and to ensure success at the end and say we have done a good job.
So that makes sense at a high level, but I thought I heard you say that if you look at them hard, sometimes risks turn into opportunities. Can you give me an example? How does that work?
Yeah, Andrew, when I dealt with a few risk analysis sessions with industry folks, and I can tell you that in one occasion that we were doing a project in Fort McMurray, and when we went through the complete risk analysis process, which I'm going to explain to you later, when we identified few risks, and then when we look at the impact of the risks to the project schedule, we realized that we could not maintain the time challenge in terms of the number of weeks or the months to complete the project. And at that moment, we felt that I think we need to look at some alternate designs so that you could cut down the time duration of the project. So the team was very committed. They look at some alternate designs. And as a result of that, we did the same thing. We look at them and we simulated to find out what's the new project duration. And then we realized, yep, we could achieve the time duration, right? And similarly, I can think of another example which I can even speak about it, openly. The Olympic Oval restoration that happened about 12 years ago at the University of Calgary. When we look at the risks, we had a big challenge in 2011 September because the facility was already committed for other clients for practicing. As you know, that this is the place that we call the fastest ice. And when we look at each of the risks, we were very, very determined. The project was so committed, and they came up with some creative solutions to reduce the time duration of the project, right? That's why I'm saying that. So sometimes you look at the risk in a negative way, but if you're committed to come up with a better solution to deal with the risk, it creates an opportunity to come up with a better design, maybe more efficient design, maybe a more sustainable design, right? And maybe a more creative design that help the project team to achieve the outcomes of the project in terms of reducing the duration, reducing the cost, maybe enhancing the efficiency, and things like that. So that's what I meant by don't always look at the negative side of the risks. Look at how the risks can create additional opportunities.
So Nate, Janaka was saying there, he gave an example of physical design, physical risks, simplifying designs. In the cybersecurity space, a lot of people face that same problem when it comes to patching. Imagine, I don't know, a power plant with 4 generating units. Each unit has, 100 PLCs. If your PLCs are on the same network as your control system, which is on the same network as your plant system, which has a firewall going to the IT network, and the IT network in turn has a firewall going out to the internet, that's a very highly connected environment. Any security assessor coming in is going to look at this and say, you really need to patch really aggressively everything on your industrial network because it's so exposed to the IT network and to the internet. And patching is really expensive. I mean, you would have to take the plant down in order to change the firmware on the PLCs. And you don't want to do that. You want to keep producing power. And you need to test these new firmware images extensively. A lot of people look at this and say, let's not do that. I know that was sort of the risk that was identified, and the obvious fix to, we're exposed to attack is to fix the vulnerabilities. But what a lot of people do is what's called compensating measures. They will put additional layers of firewalls in, they'll put additional layers of security, they might throw a unidirectional gateway in, they might air gap the safety systems so that they simply cannot be compromised. And in this way, they reduce the risk by changing the design in such a way that you don't have to do the really expensive patching thing anymore. So yeah, what Janaka is saying here makes a lot of sense. Okay, so big picture risk. When you're looking at a project, how do you get started with risk management?
The main key component is that especially the risk management. I'm talking about large capital projects. We always look at the very beginning of the project how we come up with a better risk process to identify the risks, and then we can quantify the risks so that we can come up with a better risk response plan. And that's where it's important to bring the key stakeholders who are involved in the project, and who has expertise and knowledge about similar projects in the past, and so that they could actually provide the input for the current project. So before I get into the steps of that, I think we always emphasize share the current information that you know about the project, so that the participants involved in the risk analysis can understand it, come up with a better risk identification. And so when we look at the risk identification, we want to ensure that everybody is committed to identify the unique risks that are relevant to the project, right? And that's where we ask the question. I mean, like, for example, when we identify the risks, we have to think about right away how we're going to deal with the risks, right? So sometimes we ask the question, the two important things we ask about: how urgent, how important, right? So I can refer to Stephen Covey's time management matrix, where Stephen Covey mentioned about four, like a 2x2 matrix, in terms of one side is on the urgent, the other side is on the important. So, for example, we get what we call the reactive quadrant, where it's actually urgent and important. That means there's an important risk, there's an urgent risk, and there is a different way of dealing with that, right? Then there's a quadrant number 2, which is not urgent but important. That means we have time to really identify them. We can, we can actually proactively deal with that risk, so that the team is aware what to do. And then comes the quadrant 3, which is not important but urgent, right? Which is also, it's a bit of a reactive nature. At the same time, it is difficult for us to reject it. We have to deal with it, right? We have to deal with it because it's so urgent. And then so we need to deal with it. And then comes the fourth quadrant, which is like not important, not urgent. So there's no drivers here, right? And then do we really want to spend time in looking at them, right? So coming back to that step number 1, as I said, the identification is really, really key. If the team is not identifying the risks properly, then we won't be able to come up with a robust risk management plan.
Yeah, so what he's referencing there, I've heard this for years now as the name of it being the Eisenhower Matrix, and it being applied to the traits of successful people. But I guess the point he's making is that it could be applied to risk more easily because it's sort of universal.
That's right. I think he attributed it to Stephen Covey, who I think documented it in one of his books. I don't know, was it 7 Habits of Highly Effective People? I'm not sure. But yeah, it's I think of it as I recall being introduced to it as a time management matrix, but it applies to risk as well. I mean, in the cyberspace, what are we talking about? It's something that's both urgent and important. There's ransomware on the OT network. This is an emergency. All hands on deck. Fix this problem. That's urgent and important. Not urgent but important is the risk assessment just came back. The security assessment just came back. We're in trouble. We have to fix these problems before ransomware gets into the control network. An example of, not important, but urgent. We urgently need to change all of the passwords in all of the devices in all of our substations. Why? NERC SIP says you have to do this. Yeah, but those substations, they're heavily defended. We've got security in there 9 ways to Sunday. Nobody can get in there with a password and mess with it doesn't matter. If we breach the standard, we risk $1 million per day of non-compliance fine. Fix this problem, fix it now. I don't care if it's not important security-wise, it's urgent compliance-wise. So yeah, this matrix, very much applies in the cyberspace.
In the beginning of the industrial security revolution, engineers were told to use IT security principles. Protect the information, we were told. We knew this was a poor fit, but it was all we had. Today, the top security priority at industrial sites is safety. Don't kill anyone. Don't cause an environmental disaster. And the second priority is reliability. Do not shut down our factory or infrastructure. Today, safe and reliable operations use unhackable protections from cyber risks, not just cybersecurity. For a deeper look at the evolution of the revolution, we invite you to download Waterfall's report on the emerging consensus for industrial security engineering. You can access the report at the Waterfall website, waterfall-security.com/engineering-consensus. Or just go to the resources menu and click on white papers and ebooks.
Okay, so we've identified the risks. We've got our matrix of urgent versus important. What's the next step?
The next step is this is interesting. When I've done many of the facilitation of risk analysis sessions, people come up with all kinds of risks, right? Then the question is, do you really understand the risk? If somebody asks you about this particular risk, can you justify that this risk is relevant to this project? So then we ask questions like, do you have background understanding about this particular risk? Have you seen that happening in other projects? Do you think it's relevant for this project? If it happens for this project, would you be able to really analyze the problem? Because the reason why we ask the question is, questions are, if you identify a risk and say, hey, this is a high risk, it's going to be the impact is going to be quite significant. How do you determine those if you don't understand the risk? So that's what we call the qualification. So we go through what we call a step after the identification to qualify the risks. Are you really champions of these risks so that we can take the identified risks into the quantification stage? But before that, we need to make sure that you understand the risks. And if someone else in the team asks a question, would you be able to defend whether these risks are relevant for the project? Okay? And once we pass that stage, then we can go to the risk quantification stage to determine two things. What is the probability of occurrence of this risk? And if that risk occurs, what would be the impact of the risks to various aspects, right? And I can say that one, for example, as I said, my background is in more on the capital projects. The two key things we always talk about, the risk management, is how does these risks impact the cost of the project, how they impact the time of the project or the duration of the project. But you can also look at other things. The impacting categories could be a reputation, safety, the performance, right? So you can actually say, okay, if this risk happens, let's quantify to see that what's the probability of occurrence of these risks or the impact if these risks happen, right? And that's where, especially when we are dealing with risk analysis with stakeholders involved in there, we want to make sure that everybody really understand the process of the quantification, and that's where we always adopt a standard methodology to look at the probability of occurrence. For example, if I say, oh, you know what, I have this risk which is, very likely that it's going to happen. So somebody would ask the question, what do you mean likely? Can you define what's likely? So is like, for example, Andrew, even between you and I, if I use the word likely in a subjective term, what does that mean to you? And then if I look at that likely, how do I interpret likely? So that's where we always look at and come up with a standard methodology that can say, you know what, this risk is, likely means it is 40% chance happening, right? Or is it 50% chance happening? So we come up with a quantitative methodology to define what do we mean by a subjective meaning, and then convert that subjective meaning into a quantitative meaning.
So that makes sense. But we're talking about, risk. We're talking about things that might not happen. I might say, you're operating a large consumer goods factory and competing with the same kind of factory in another country, and that country has an active industrial intelligence wing in their government, and I think it's very likely that the large consumer goods factory, laptop factory, is going to be targeted with a nation state grade and intelligence agency grade cyber attack. You might disagree. How do you resolve these things about events that haven't happened yet?
I mean, this is where, Andrew, like, there's two things. Sometimes we, when we look at the risk management and identification, we identify which ones are the strategic risks, which ones are the tactical risks. In the project management domain, we consider the tactical risk management is available at the projects for the project people to handle, whereas the senior management will determine the strategic risks. Even the existence of a project depends on how they look at the strategic risks, and then if they think, like the example that you've given, is actually more geopolitical type of thing, which is actually a strategic type of risk, which would decide whether we want to go ahead with the project or not. But anyway, the challenge that I have faced in the quantification of the risk is that, do we think the same way? Like, for example, I mean, I sometimes use a criteria, like it says likelihood of occurrence. We define them in 5 different subjective ways. Almost certain. Now, what is almost certain means to you and me? So for us to really understand the same consistency, then we define and say almost certain means that it's going to be anywhere about 90% probability. A likely means it's a high risk that we can say between 70 to 90%. A possible means 30% to 70%. Unlikely means 10 to 30%, and rare means 0 to 10%. So we come up with a framework that everybody is thinking along the same definitions, so that when we identify risks and when we quantify, that we get consistency from everybody. And I think that is also important in terms of when we look at the impact. So I'll give an example on that as well. Like, if you were to come up with a criteria for impacting, the simplest way is maybe on a range of 10, we can say, what a 10 plus means it's a catastrophic impact in terms of time impact or a cost impact. And you can say a serious means on a scale of 10, maybe 8 to 10. A moderate means anywhere from 4 to 6. A negligible means 0 to 2. So, for example, we could come up with a criteria that actually has the words called catastrophic, serious, severe, moderate, minor, and negligible. But then we can say, what do you mean by catastrophic impact? Catastrophic impact means, depending on the project value, like we could say that means we are talking about a 5 million additional cost to the project, and we are also talking about 6 months delay, right? Versus a negligible means we are talking about maybe up to $10,000, cost impact with a 1 week of delay. You see? And I think we need to come up with a subjective nature of the impact and also put a value associated with that one in terms of the cost and the time, so that everybody in the team, when we analyze the risks, that there's a consistent mindset about these two things, the probability of occurrence and the impact. And I'm sure, Andrew, you could think of many examples in your domain in terms of how do you define the probability of occurrence with relevant to the risks, and then also how do we see the impact of the risks.
So Nate, the key word I took out of that was strategic, sort of strategic versus tactical risks. In a large organization, think, I don't know, a power utility with 40,000 employees. Lots of different people are involved in lots of different kinds of risk management at lots of different levels. I mean, individual technicians who drive out to a high voltage substation, they do not touch anything in the substation unless they know that it's been de-energized. Ideally that, they've de-energized it themselves so that they don't, get 200,000 volts, flying through them and killing them on the job. Whereas, senior management would tend to deal with risks of, I don't know, an earthquake collapsing the head office and having to relocate, the functions of the head office to a backup office on an emergency basis. But at what level of an organization should you be dealing with cyber risk? And I think the answer that I heard, sort of in terms of general principles, is that the highest levels of the organization have to be dealing with strategic risk. And, strategic risk is risk that puts the entire existence or the mandate of the organization at risk. So, in the example of the computer factory that I gave to Janaka, and the interference with the factory by a foreign intelligence agency that's trying to give their own factories in their own country a competitive advantage, that interference could be existential. It could drive the computer factory out of business. For example, if pricing information has been stolen from the IT network in this factory, and this allows the factories in the other country to by 10 cents, by $1, undercut the price of the products produced by this factory, or if the intelligence agency has wormed their way into the operations network and has been tampering with the devices, the PLCs controlling production and introducing flaws, defects into the product that have to be repaired at a massive cost. You could, with this kind of interference, you could drive the factory out of business, the company out of business. That level of threat is something that needs to be discussed at the board level, in my understanding. That's a strategic threat. Lower level threats of, I'm sorry, if we mess with if we don't comply with the law regarding, I don't know, electromagnetic emissions or different kinds of compliance risks might be dealt with lower in the organization. But, strategic risk has to be dealt with at the highest levels, and lesser risks are dealt with, elsewhere is what I took away here. Okay, so we've identified our risks. We've, in a sense, prioritized them. We understand which are strategic. We've quantified them. What's next? How do we deal with these?
So now you could actually you could come up with a nice risk matrix, right? And the risk matrix will tell us, based on the probability of occurrence and the impact, which ones are high risks, which ones are low risks, which ones are in the middle. And that's where you look at it and say, hey, we have a high risk, which is the probability of occurrence is very high. It's a catastrophic risk. And then do I want that risks to come all the way down to a low level where we want to make sure that, it's a rare occurrence of that particular risk, or the impact is going to be very negligible, right? Or somebody said, you know what? No, let's also look at it in an alternate scenario. We want to see that risks could could occur, like, it could be possible to occur. If that happens, that maybe there's a moderate impact because of that risk, right? So that's where we look at now a framework about risk response planning. And that's where the two keywords come back again. The one that I mentioned earlier called the proactive versus reactive, right? So, and actually, my domain, when I do things, I actually have a kind of a decision tree built into both proactive risk management versus reactive risk management. So what are the different options available when you are dealing with a proactive risk management? Because we see that potential risk coming in, but we do have time to eliminate the risk or to mitigate the risks or to accept the risks or to transfer the risks. The four things that I can elaborate on that, right? But if you're now dealing with proactive versus reactive, how do we deal with it? I'll give you like, a kind of a simple decision tree. We can actually say, what, the current probability of a particular risk is about 80%. But we have three choices. We can eliminate it. That means there's an 80% chance we want to eliminate it, like we want to make it into a 0%, that we will never see this risk. Okay? Or we can say, what, the current probability is 80%. I mean, let's try and mitigate to about a 20% probability, a 10% chance of this risk happening, right? So what can we do proactively to mitigate this risk occurring? Or we can say, what, I think this is kind of a risk that, in a project environment, there are various key stakeholders in there. Let's say we have an owner or a consultant or a contractor or other parties, and say, I think for this particular risk, it may be better for us to transfer the risk to a party that could better handle this risk. And so we can think of three options: eliminate, mitigate, or transfer, depending on the nature of the risk. But if you were to look at a proactive nature of risk, the word eliminate does not exist, because reactive means that something has already happened and you cannot eliminate it now. So your choices are either to mitigate the impact of the risk, which means that we, through the risk analysis, we identified if this risk occur, it's $100,000 impact. But I can mitigate this one by maybe spending maybe $60,000 so that the impact could be cut down. Or we can even think about it and say, how do I mitigate the impact of it? Maybe we do something that it will not have the same $100,000 impact, right? Or, what, yes, we can see the signs of this risk, but I think rather than me as a stakeholder handling the risk, I could probably transfer this risk, say, into another party who has a better authority or the accountability to handle the risk, and we could do it, transferring the risk and then handle it that way. Or, what, the risk has already happened. There's nothing much we could do it. Let's accept it and deal with the problem, right? I mean, when you are, I've also done some work in the disaster area, right? Particularly the natural disaster area, with respect to tsunamis, and then also the tornadoes, and that's where sometimes you have to accept the impact of it. I mean, it happened, and how do we deal with it now, right? So depending on the nature, as I said, proactive versus reactive, you could come up with a decision tree that will show different options, and also will show the consequences of those options to the project, so that you can make it successful and dealing with the risks.
So, I mean, one of the things that now that we've had some of the big picture here, one of the things that always puzzled me is when you're doing, I get deeply involved in cyber risk management, but not so much, management of the risks of earthquakes or of, fires or of, pandemics, who knows what. And so, if let's say you're building, I don't know, a hospital, the systems that you're putting in place have to protect the confidentiality of patient information. The design for the structure has to address the risk of earthquakes in the region because we can't have the structure collapsing on all the patients. The design of the electric system has to, allow for backup power supplies if the main power supply fails, because you got to keep your patients alive, and electricity is used for that. So you got different kinds of risks that you're managing. Do you ever have to trade off one against the other and say, this one's more important, I'm going to focus on it, the other ones I'm just going to accept, or is something else going on here?
I mean, Andrew, I think two different things to look at it. One is that if we identify exactly the same two risks that you mentioned, if they are important, if they are that been identified in our risk matrix through the probability of occurrence and the impact has been critically that we need to handle it. How we handle it, proactive versus reactive, is two different things. But also the second one is at what stage this could happen. Like, is it happening during the design stage? It could happen either during the construction stage, or is it happening in the commissioning stage? So if they're both important and we need to tackle them, we don't trade off. We deal with different strategies to deal with it, right? One could be proactively trying to eliminate that, or maybe the other one could be we will be reactively mitigating, right? So that two different things. I think as the time goes, cybersecurity related risks are really being critical in many of the engineering and construction projects, because the example you gave in hospitals, research facilities, universities are becoming really critical now. So that we don't trade off, but if it's important and if it's high, then we must find solutions to deal with that.
So Nate, let me paraphrase what I just heard there. I mean, the question that's been sticking in my mind for some time. I mean, at Waterfall we work with heavy industry. We work with people who are dealing with powerful, dangerous physical processes. They deal with risk every day, and what I've heard from time to time from different stakeholders in these organizations, depending on the organization, is Andrew, we're not going to worry about cyber for now. We have bigger fish to fry, and they talk about other risks. And this was, in a sense, my goal in bringing Janaka on, is to try and understand how does cyber fit into the bigger picture. And what I just heard him say was, look, Andrew, if you've got a strategic risk, if the existence of the organization, if the mandate of the organization is faces a serious threat, look, you have to deal with that. The board has to deal with that. The executive has to deal with that. You cannot ignore material risks. It doesn't matter if you have lots of risks on the table. You have to at least think about every one of these risks. And that's an insight I didn't have before, that the folks deal with, senior decision makers, they deal with the risks, major risks due to fire, due to earthquake, due to cyber, sort of independently. But, it still begs the question, where did that question come from? And this is what, let's listen back in again. Sort of my next question is a little bit clarifying in terms of when can you trade stuff off? And it turns out it has more to do with different threats that have the same consequence. In a sense, it's the same risk as opposed to different risks. But, if you've got different important risks, the lesson here is you have to deal with each of them. Instead of talking about, risks with very different outcomes, leaking patient information versus the building collapsing, can we talk about risks that, in a sense, have the same consequence? A solar farm might have motors to move the solar panels to track the position of the sun. And they might have those motors because if the motors are working properly, they produce, the farm produces twice as much power in a day. If ransomware gets in there and cripples the computers that control the motors and the panels freeze, you only produce half as much power as you expected for the day. But you also might have mispredicted the weather. I mean, the weather is variable. Sometimes it's cloudier than you expect, and you only produce half the power in the day that you thought you would. You might have a cloudy day dozens of times in the year. You might have a ransomware incident once every 2 or 3 years. When you have, in a sense, the same outcome of different causes of risk, is this a time where you might legitimately say, I'm going to trade off how much money I spend on one versus the other? Is this what makes them comparable?
Yeah, I mean, and I think that's where I gave that scenario called if-then scenarios. Like, for example, you could isolatedly look at each one of them individually, or you can look at them in a combined way. Like, for example, what if a ransomware as well as a cloudy nature would have a more cumulative impact to the farm, right? Versus you cannot look at individually, the cloudy situation. As you said, the weather is very random and we don't know that one, versus a ransomware. So that's where I think that's where the team needs to look at, by looking at all those possible risks, coming up with scenarios. And you look at those scenarios, and then that's where the tools like simulation or decision trees, or as I said, this analytical hierarchy process like AHPs, we can evaluate each of these scenarios and see what's the impact. And then maybe as a result of that, you could even come up with a better risk management strategy, right? And that's the beauty but the key is it's a committed effort to identify these scenarios. When you identify the scenarios, you can actually, analyze it and then come up with better ways of handling. And then that also will determine, we probably have to proactively deal with these things. Maybe we need to invest upfront to deal with it versus, looking at the reactive scenarios of managing risks.
Well, thank you, Janaka. This has been educational for me. Thank you so much. Before we let you go, what should our listeners take away from this episode? What's sort of the number one takeaway for you?
The key message that I want to pass that one as an academic, as well as somebody who had dealt with industry and worked with industry on the risk management side of things. I've seen people are making a commitment to do a proper job of a proper risk management process, where sometimes I see them as a procedural thing or an ad hoc thing. They won't have the commitment. They're simply doing it because they have to do it. So therefore, my message is that it's really, really important, and particularly in your domain about the cybersecurity area, to make sure that we do a proper risk analysis to ensure that we identify them, we really understand them, we qualify them, we quantify them, we come up with a better risk management, risk response options. We look at various scenarios of if-then scenarios to see whether, what's the best way of handling them, right? And that's where we can help from the University of Calgary. I mean, we have experts here in terms of the cybersecurity area at the University of Calgary that we have, through our computer science department, and then through our Schulich School of Engineering. And we have experts actually in other areas, in Faculty of Law, Faculty of Arts, in terms of the policy side of things, as well as we have experts in the risk management through the project risk management side through the Schulich School of Engineering with Center for Project Management Excellence. So there's a lot of things we can help to support the cybersecurity area. And then I hope that my message is properly relayed to you in terms of make a commitment to do a better risk comprehensive process, and you will be happy at the end of the day.
All right, so that was your interview with Janaka Ruwanpura. Andrew, do you have anything to take out this episode?
Yeah, I mean, I'm very grateful to Dr. Ruwanpura for joining us. Um, I don't know, I might have mentioned I've been writing a book on, one of the big topics in it is cyber risk for years now. I'm hoping to be done by October. But something that had confused me, time and again is talking to people doing risk management, and hearing stories like, look, we have bigger fish to fry than cyber. We're not so much worried about cyber taking down one of our high voltage substations. We worry more about squirrels eating through the insulation, getting electrocuted, frying themselves, and short circuiting everything and shutting down the substation. And I'd always tried to, understand how does that fit into the big picture? Does this really make any sense? And what Janaka cleared up for me was, look, strategic risks, important risks, you have to deal with them independently. If they're important, they're important. You have to deal with them. You can't trade off, the risk of a fire against the risk of an earthquake. You have to deal with these. Where you can legitimately trade off is when you have multiple threats that have the same outcome. So if the cyber scenario you're looking at is one that would take down one substation, the same way that a squirrel would eat through the insulation and take down one substation, it's reasonable to say, how often do squirrels do this? How often does cyber do this? Is this a problem worth solving? If instead your cyber scenario could take down the entire grid, that's a different animal. You can't compare that to squirrels. It's a different consequence. So that bit of clarity is something that had confused me for a very long time, and I'm grateful to Janaka for clearing that up for me.
All right. Then with that, thanks to Dr. Ruwanpura for speaking with you, Andrew. And Andrew, as always, thanks for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.